Okay, think about this for a second. What if you could perform like brain surgery on an AI? Not to fix a problem, but to stop it from ever learning something dangerous to begin with. Well, today we're going to dig into a new technique that does pretty much exactly that, getting super granular, right down to the level of individual words. And really, that gets to the heart of one of the biggest questions in AI safety, right? How do you actually stop an AI from picking up dangerous skills? I mean, instead of trying to teach it right from wrong after it's already learned everything, what if you could just make it so it never even had the capacity to be wrong in the first place? So here's how we're going to break this down. First, we'll tackle the big AI safety dilemma. Then we'll get into filtering the data stream and how a new, more precise scalpel is changing the game. After that, we'll see if it actually works. Spoiler, the results are wild. Then there's a really unexpected benefit we've got to talk about. And finally, we'll look at what this all means for the future of safe AI. Ready? Let's dive in. All right, first up, the AI safety dilemma. And this is really the core issue, It's the thing that makes these models so incredibly powerful, but also potentially so risky. I mean, just think about it. An LLM basically eats a giant slice of the internet for breakfast. And in that process, yeah, it learns to write amazing poetry or debug your code, but it's also learning all the bad stuff too, like how to synthesize a bioweapon or run a disinformation campaign. It doesn't judge, it just learns. It just absorbs everything. And this is what leads to what researchers call a perpetual cat and mouse game. Right now, our main strategy is to fix these problems after the model's already been trained. We use techniques like RLHF to try and teach it, hey, don't answer that question. But the problem is, the dangerous knowledge is still kicking around in its neural network. And that's exactly why we see people finding new jailbreaks all the time, tricking the AI into spilling the beans on what it secretly knows. So this brings us to a totally different way of thinking about it, a more fundamental approach. What if, instead of always playing defense, trying to patch holes after the fact, we could go on offense? What if we could shape the model's abilities right from the very beginning? This idea is called data filtering, and honestly, it's pretty much what it sounds like. Imagine you're building a library for someone to learn from. You would probably pull out all the books with dangerous or harmful information before they even walk in the door, right? You're basically curating their entire universe of knowledge from the get-go. But it turns out how you filter that data, well, that matters a lot. And this is where we get to the cool part. This is where we go from using a sledgehammer to a surgical scalpel. Okay, so let's really break this down. On one hand, you've got document filtering. This is the blunt approach. If a web page or a book has even one tiny bit of unwanted info, you toss the entire thing out. It's like banning a whole shelf in the library for one bad paragraph. But then you have token filtering. This is the surgical scalpel. It doesn't throw out the whole book. Instead, it just removes the specific words, or tokens in AI terms, related to that dangerous skill. It's like taking a black marker and redacting just that one sentence and leaving everything else. And here's a peek at how it actually works. There are a couple of ways to do it. One is called loss masking. The model sees the bad words, but it's basically told, hey, see these? Ignore them. Don't learn anything from them. The other way is removal, and it's even more hardcore. The bad words are just gone, replaced. The model never even knows they were there. Okay, so that's the theory. It sounds great on paper, but the big question is, does this surgical approach actually work? Well, researchers put it to the test, and let me tell you, the results are kind of stunning. So in this huge experiment, the researchers tried to see if they could make an AI forget all about medical knowledge while making sure it still knew all about biology. And what they found can be summed up in this one number, 7,000x. So what on earth does that mean? It means this. For the biggest models they tested, token filtering made them 7,000 times less efficient at learning the topic they wanted it to forget. To put that another way, it would need 7,000 times more compute power just to get to the same level of medical knowledge as a normal model. That's insane. And you can see it right here in this chart. The effect just gets more and more powerful as the models get bigger. See those yellow and green lines for token filtering? They just shoot straight up. Okay, so what does that look like in practice? On actual multiple-choice medical exams, the filtered models performed at basically chance levels. They were just guessing. But, and this is the amazing part, look over on the right. Their knowledge of biology and other related STEM topics? Totally fine. Almost completely unharmed. The surgery, you could say, was a total success. And it gets even crazier when you look at open-ended questions. When the models were asked to just write out answers on medical topics, the quality just fell off a cliff. We're talking up to 10 times less correct, and their answers were way less relevant and coherent. Just a mess. And just to give you a real taste of what that looks like, check out this actual quote from one of the filtered models. It's just amazing. It knows the words that sound medical, but it has absolutely no clue what they mean or how they go together. It's just this hilarious, repetitive, nonsensical word salad. Okay, so we've established the method works. It's super effective at stopping a model from learning something. But this is where the story takes a really interesting twist. Something totally unexpected that challenges a huge assumption a lot of people have had about AI safety. And here's the paradox, right? The common wisdom has always been that for an AI to know it should refuse a dangerous request, it kind of has to know about the dangerous topic in the first place. So if you just make it ignorant, doesn't that make it even more dangerous? Won't it just be totally unpredictable when it bumps into that topic? Well, it turns out the data says nope, not at all. This chart here shows what happened when they tried to teach the models to refuse these requests. And get this, the models that had the medical knowledge surgically removed with token filtering, they were twice as good at learning to say no as the regular model. Let that sink in. Removing the knowledge didn't just work, it actually made the model easier to control. This completely flips a core assumption in AI safety on its head. I mean, these results are pretty profound. So let's wrap this up and pull together the biggest takeaways and what this means for the road ahead. All right, so here's the rundown. First, token filtering is not just some cool idea. It's a super precise and effective way to stop an AI from learning specific things. Second, and this is a big one, it actually gets more effective as the AI models get bigger and smarter. Third, it's way more robust to the kinds of attacks and jailbreaks we talked about earlier. And finally, that huge surprise. It can actually make the models easier to align and control, not harder. So this research really opens up a whole new playbook for AI safety. It's a huge step forward, but it also leaves us with this massive, looming question. We're showing that it's technically possible to perform this kind of neurosurgery on an AI, to carefully pick and choose what it knows. The how is getting clearer, but the bigger question, the one we all have to grapple with, is who gets to decide what an AI should and shouldn't know?